So good morning, everybody. It's Monday. Welcome to class 5. I'm not doing any demonstrations today. Basically, we got ahead of schedule a little bit with chapter 2. I finished off chapter 2 pretty much on Friday. And my plan was to start on chapter 3 on forces on Wednesday. So today what I thought I would do is go over some practice problems with you, which I gave out in a quiz, and try to answer questions. Thanks about the paintings, they're mine. I did them in gouache. Good morning. Can you please take up question 80? Yeah, that's like the first thing I'll do is go over question 80. So, so let's do that. Let's share the screen. Class 5. So again, chapter 2, problem-solving examples that are relevant to the synchronous midterm that's coming up. So this was that question 80. Some people in a hotel are dropping water balloons from their open window onto the ground below. The balloons take 0.15 seconds to pass your 1.6 meter tall window. So how does that work? Well, let me just make sure I can also see the chat window here. Oh dear. Chat. Can't really see it, which is weird. Oh, there it is. I see it. Okay. And yeah, this was on the, or this one's on the quiz, but the quiz is supposed to be have unlimited attempts, but the real one won't. Okay, so this one, let's take a draw of what we think is happening here. I think there's a window, which is 1.6 meters high, 1.6 meters from here to here. This is the window. And what's happening is that there's a water balloon which starts at the top and then goes down to the bottom. And it's going to have some maybe speed V1 and some speed V2. But the point is that T2 is equal to 0.15 seconds. This is the time to travel the height of the window. So that's basically, I think, what they're saying. And then they're asking for find how far above the top of the window was the balloon dropped from rest. So assume initial drop, they didn't throw it down, was from rest. Okay, so what I'm going to do, my strategy here is that I'm going to divide the motion into 2 segments. The segment before, segment 1, I guess, is before the balloon gets to the top of my window. Because it arrives at the top of my window with some initial speed, V1. And it got that speed because it was falling from rest from somewhere way above me. So, so V initial for segment 1 is 0. That's initial. And then the final speed is V1. That's the final speed of that first segment before it gets to my window, and that's going to be the initial speed for the second segment. What we need here is, Y1, the distance traveled. How far above my window did it start from rest? Traveled. And we don't care about the time, about how long it took, T1 time. Okay. And then there's going to be segment 2, seg 2, which is the window part. So V1 is initial and equals final of segment 1. Okay, and T2 is equal to 0.15 seconds. This is when it's actually traveling past my window. And the Y2 is the 1.6 meters. And for this one, we don't care about that final speed at the bottom of the window. I've run out of room here, but I'm going to go to the next page. What we're going to do for segment 1, the equation, I think, is going to be the thing that doesn't care about time. And then for segment 2, the equation is going to be the one that doesn't care about final speed. And then we're going to solve that out. Let me just go up to participants for a second here. If I can find it. Participants. See if there's any raised hands. Ava, do you have a question?
Yeah, I was wondering, what does the T2 0.15 seconds represent?
So that represents the total time of the second segment. So there's 2 segments of motion. The balloon dropping from rest down to the top of my window, and that's going to take time T1, which we don't actually care about. And then the second segment is going from the top of my window to the bottom of my window. That's going to take time T2.
Oh, okay. Thank you.
Yeah, sure. And Tang, did you have a question?
Yes, I just wanted to find out about the entire exam and quiz. One, is there going to be error carried forward if we have a set of questions where if you get one question wrong and an answer on that question is reliant on the next question?
The answer to that one is that no, they're all separate questions.
Okay.
Not related to each other.
Okay, and the next question is, how's the test going to be administered? Like a question like this, how, if somebody, sorry to be a little bit negative, if somebody were to get the question wrong, is there credit for your working out, and how will that be managed?
Yeah, that's a great question. And normally with a written midterm, there would be, you actually write all this stuff out. So for these Quirkus quizzes, there is no partial credit. It's trying to find if you got the right answer.
Oh, wow. Okay.
Okay.
All right. But thank you, sir.
Sure. Not ideal, but again, during COVID times, I can't think of another way to do this. Let's continue with this. So I'm going to go, it's going to go blank because I'm going to the next window. So that was a good time to take those questions. Those are both good questions. So again, for segment 1, I'm going to use equation 2.7 because I don't care about the amount of time segment 1 did. And I'm going to solve for V1 because that's V1 is the same variable in both problems, and so, or both segments. So I'm gonna, it's one of my tricks. I solve it for in one segment, V1, solve it in the other one, V1, and then I set V1 equal V1 for the 2 segments and solve for the thing I care about, which is how far Y1 was, how far it was in the first one. So this is 2A times Y1 minus Y0 equals V1 squared minus V initial squared. And remember that V initial for this motion is 0 because the balloon is dropped from rest. We're going to set Y0 equals 0, I guess. And we're going to set A is equal to G is equal to the 9.8 meters per second squared. It's all free fall. So you get 2 times G times Y1 is equal to V1 squared. So V1 is equal to the square root of 2 times G times Y1. Before we run out of room here, segment 2, I'm going to use equation 2.6 because the thing I don't care about there is that final velocity at the bottom of the window. And again, I'm going to solve for V1, the initial. So here we've got Y2 is equal to V1, the initial now, times T2 plus 1/2 G times T2 squared. I'm in trouble making the Y there. It's supposed to be a Y. 2. And then, so we've got V1 times T2. To be a little careful with all your little subscripts here. Y2 minus 1/2 G times T2 squared. So V1 here is equal to Y2 minus 1/2 G T2 squared, all divided by T2. And so then we're going to set V1, which we calculated from segment 1, equals V2, which we calculated from segment 2. So we're going to get square root of 2 times G times Y1 equals Y2 minus 1/2 G T2 squared divided by T2. And then just solve it out for Y1, which is what we care about. So to get rid of that square root, I'm going to have to square both sides. Over T2 all squared, and then just divide. So Y1 is equal to 1 over 2 times G times all that stuff. Y2 minus 1/2 G T2 squared divided by T2 all squared. So I'm going to have to plug in all those numbers. It's 1 over 2 times 9.8 times 1.6 meters minus 1/2 times 9.8 times 0.15 squared divided by 0.15 squared. I typed that into my calculator and I got 5.03 meters. So the way they should look, they should look 5 meters above my room. For people who drop the balloon. Okay, looking at some questions here. Oh, this is a good question. Is it important to identify where it's up and down in the question? So that's actually a great question. I missed that. I'm going to go back here. I'm going to, in my sketch and translate, I'm going to define, I should have mentioned this, plus equals down. So what I did there, this is an old trick. All the motion is going in the downward direction. So I've set the acceleration as positive 9.8, and all of my plus variables are to be in the down direction. It's just speeding up. So sorry about that. Let me actually, while we're here, let's run a little poll. Here's the motion diagram of a car going along a straight road. Which velocity versus time graph matches this motion? So there's A, B, C, D, and E. So I think I'm going to launch the poll, let you think about it for a little bit. Launch the poll and see what you guys think. This is sort of a conceptual question. There will be some quick conceptual questions on the quiz. And also while you're voting for that, maybe Robin Liu, do you have a question you wanted to ask?
Yes.
Yes.
So for the previous question, do we
Yeah.
round to 2 significant digits or?
That's another good question. Yeah, it should have been 2, so 5.0. That's a really good point. I should fix that.
Thank you.
Yeah, because the 2 input numbers were 0.15 and 1.6. So good point. But when it's multiple choice, hopefully that won't be a big issue. But thanks for that. Going back to polling, I'm gonna cut off the polling. Give me another 5 seconds to vote in. Okay, seeing 91% of you have voted. So I'm gonna end the polling and see what people are saying here. So most of you are saying D. Sorry, 55% of you said D, 19% said A, 14%, or sorry, 19% said B, 14% said A. So what I think is that right here, since it's going from right to left, it looks like right here is where T equals 0. That's my feeling. And then for these first few seconds, 1, 2, 3, or whatever, it might be milliseconds or some fraction of some time units, there's going to be Vx is negative. And then for the next same amount of time, Vx is, I guess, more negative. It gets faster. So faster means that the absolute value is increased, but it's negative, so it means it gets more negative. So the only one that does that is, yeah, is answer D. Sounds good. And while we're doing things, I want to do this velocity graph of an object that is at the origin, x equals 0, at t equals 0 seconds. So at t equals 0, x equals 0, and v sub x versus t graph is given. So it's hard to break this down into a lot of steps here, but basically the whole simplifying diagram thing is just to know that the area under the Vx versus t graph gives the change in position. So if that's x0 equals 0, then x minus x sub 0 will come from this area. So all you do is, I guess I'll call that delta x. So delta x is the area, why don't we call it this? We'll say A1 plus A2. Where you can say that this is A1. Area of this looks like a square actually, and A2 is this triangle. Square, maybe a rectangle. It's not really a square because it looks kind of square-like, but remember there's different units on the bottom than there are on the top. So we'll call it maybe rectangle and triangle. So it's going to be like length times width is the area of a rectangle, plus 1/2 base times height is the area of a triangle. So this first A1 is going to be 2 seconds, is this sort of length or whatever, times this width, 4 meters per second actually. That's that rectangle, and then plus 1/2. The base of the triangle is actually 4 minus 2. That's actually also 2 seconds. And the height of the triangle is 4 meters per second squared. Sorry, 4 meters per second. That's velocity versus time. So it's delta x is equal to 2 times 4 is 8 meters. 2 times 4 divided by 2 plus 4 meters. So when you're careful about this, that second cancels that second cancels that second, and you get meters. So it's 12 meters. And x0 equals 0, so x final is equal to 12 meters. Okay, look at people who've typed questions and answers. Someone said they're still waiting for the email for the practical, but their practical is tomorrow. I'm sorry about that, but hopefully you get it soon, and hopefully maybe you should check to make absolute sure you can get emails in your Toronto. But it doesn't really surprise me as this is our first week. I could ask April about that today though. Yeah, just the area under the graph is 12 meters, and so that gives you the distance traveled for 4 seconds. Anonymous attendee said, will the positive direction be defined in the midterm questions? Well, it wasn't for question 80. All it was said was, oh, well, you have a window and it takes, 0.15 seconds for it to travel the 1.6 meters. Where are the raucous guests? So that's sort of an English description of what's going on. And in order to solve the problem, I decided to define positive down so I wouldn't have a lot of negative numbers. So it's a decision that you make, just like an assumption that you make. You assume that the balloon was dropped from rest and things. So we're using problem solving and all these little skills to try to find a numerical answer. And Liel Ronan, did you have a question? You have your hand up.
Hi, can you hear me?
I can hear you fine, yeah.
I was just wondering, for the question 80, you set up a system of equations.
Mhm.
How would you know to do that? Like, is there a specific type of question where there's certain information that you see and you're like, I need to set up 2 equations here?
Yeah, so that's a great question. It is a lot about practice, but I guess that particular question, I didn't know that initial velocity, and I didn't know the final velocity. And there just weren't enough knowns. Like I couldn't solve it out by just looking at the motion in front of the window. So what I had to do is think about, well, I guess it matters what happened before it got to the window. And so then I had 2 segments of motion. So the trick there, when there's 2 segments of motion, is to make the final velocity of the first motion, the final position of the first motion, become the initial velocity of the second segment. So it's a great question, Leo, but I kind of did it with practice. And then once you've got those segments, looking for the variable you don't care about, and then going back to that last day's Friday slides of looking at the 4 equations of constant acceleration and trying to find which one has the knowns that you know and is missing something that you don't care about for that segment. Let me do some more examples and maybe that'll help a bit. Here's another poll. Here you have a graph of velocity versus time for a hockey puck shot into a goal. So it looks like this. Which of the following position graphs matches the velocity graph? Heck is polls here. There it is. Six of you have voted E, so that's kind of funny. Okay. Okay, so let's discuss this one. Another 5 seconds to vote. I'll give you what I think here. So results are 78% of you were saying D, which is actually the one that I liked as well. So what I'm thinking here is that what you've got is you've got constant speed, that's positive. Speed equals the like a positive slope of X versus T graph, okay? Constant slope, and then all of a sudden, you've got 0 speed, meaning that X is constant. So that's sort of the physical interpretation. Another way is that as you're going along here, as you increase time, the area under this steadily increases until you get to zero velocity, and then the area as you keep going doesn't change, stays the same. So in both cases, you got constant slope for a while, and then the thing just sits there at rest. So D was the one that I liked. As for some of, this question answer thing, and there's the chat, there is definitely a lot of you who are saying in the chat that you haven't gotten a link to your practical Teams meeting yet, even though your practical is tomorrow. So so don't be surprised if that is the case. I will be asking April today, what the deal is with that, and when you should be expecting to get that, but you're not the only one. Anyway, I don't know where it's. Someone asked how many questions are on the September 29th midterm evaluation. So there's 10 to do in 30 minutes. Sort of similar to the quiz I gave for practice, or for the chapter 2 quiz, but there'll be some from chapter 3, obviously. So yeah, so actually that's a good question. So B has the same exact properties as D. Someone asked me, why isn't it B? The thing I don't like about B is this sudden jump in position. So what that would look like is that all of a sudden it would have to have a very, very sharp negative velocity in order for it to get down to zero position. Makes sense? Like I have to have infinitely negative slope during this time period. So that's not physical. So it has a lot of the same properties, but you can't jump at that point, and that's why I chose D. Great question. Okay, let's do another question, shall we? This one is just a unit conversion question. So Shannon drives at a constant speed on the highway. She measures the time between, so let's write it down, constant speed. I always like to write down what's going on. That's important. She measures time between passing successive km markers separated by exactly 1.00 times 10 to the 3 meters. Okay, so fair enough. So x equals 1.000 times 10 to the 3 meters. Okay. And then the t is equal to 48 seconds. All right. So constant speed just means that v is equal to, we're going to call it x divided by t. That's kind of the one equation of constant velocity, is just its distance divided by time. Whereas there's like 4 equations of constant acceleration, where you have to find how the time is, or velocity is changing. So this is pretty simple. So just v equals x over t is going to be in meters per second. Meters and seconds. So we're going to convert. We're going to use the fact that 1 is equal to 1 kilometer divided by 1,000 meters to convert to kilometers. 1 is equal to 60 seconds divided by 1 minute, and 1 is equal to 60 minutes divided by 1 hour. There's 60 minutes in an hour, and there's 60 seconds in a minute. So the way it's going to look is x in meters divided by t in seconds times 1 kilometer divided by 1,000 meters, and then times 60 seconds divided by 1 minute times 60 minutes divided by 1 hour, which I'm going to use just h. So I don't know if you can sort of see how those all cancel out, but meters cancels meters, seconds cancels seconds, and minutes cancels minutes, so that the only thing that's left is just a kilometer on the top and an hour on the bottom. So that's how you're going to get kilometers per hour. So I'm going to say v is equal to 1,000 meters, which was what she measured, divided by 48 seconds, times there's a 60 on the top times 60 on the top divided by 1,000. And I got V equals 75 kilometers per hour. I think. Oh, and there's even someone that says they didn't get the link of their practical, and their practical's at 1:30 p.m. today. Well, again, I don't know any of the links of the practicals, so I'm sorry that I can't help you. But you're gonna need it. Will our practice chapter Q? Yeah, the practice chapter 2 quiz that I put on Quirkus is worth, I guess, 10 homework credits. So, but you get to try multiple times. So hopefully you should be able to get that. And then there's Q&A for this question. How no? You need to find the answer. Oh, it says there. If she measures a time of 48 seconds, what is her speed in kilometers per hour? It's a good question. Gotta just read it carefully. Are there any solutions to the type of questions? Yeah, so solutions to the textbook questions, you can get those if you make a practice mastering physics assignment, which I haven't really done. But then, problem with practice mastering physics problems is that then it creates an item in your grades, and then everyone emails me and says, why do I have 0 out of 0? So I guess I could do one for chapter 3 though, and just delete the emails. I'm getting about 60 emails a day from you guys, so I'm getting a little bit behind. Okay. What do we do if we run out of time? You gotta be careful of your time on this quiz for sure. Because if you run out of time, then it's just the questions you've submitted. I found the site with the answers. I think the answers are on mastering physics. That's a good way to send them. Okay, let's see what else I've got here. I wanted to do another poll. Sort of poll time. So it's sort of interesting. A Toyota Camry can accelerate from rest to 100 kilometers per hour in 6.5 seconds. A Porsche 918 Spyder can accelerate from rest to 100 kilometers per hour in 2.6 seconds. So they'll test these cars by just whoever's in there steps on the gas and goes as fast as they can, and they time how many seconds to get up to highway speeds, 100 kilometers per hour. And since a Porsche is much better acceleration, stronger engine, it gets up to that speed in 2.6 seconds. So here's the question. During the test, which of these two cars would drive the longer distance? So actually, let's put it to a poll. This is kind of a weird one. A, the Camry, B, the Porsche, or C, they would both travel the same distance. Yeah, the test ends once the car hits 100 kilometers per hour. Starts at 0, gets to 100 kilometers per hour. Which car travels further during the test? The Camry or the Porsche? I think I'm probably going to try thinking about average velocity. What's the average speed? I think I know what the answer is. Do you want to, 5 seconds, try to click one in, and then I'll tell you what I think my answer is. Three, two, and it's got 93% have voted, so let's see what people are saying. A lot of people are actually voting for the slower car, the Camry. And so 56% of you, so that's I think I actually like it. So what we should do, I'm thinking is, here it is. So V average is, there's two equations for it. One is it's just distance divided by time. And that's even if you're accelerating. The average velocity is the distance divided by time. And if you are accelerating, V average equals V0 plus V final divided by 2. And this is true if A is constant. So actually, there's really no reason for us to think that a car's acceleration should be constant, but let's assume it is constant. Even though I bet it probably isn't for a real car and a real Porsche or Camry, even though this is questionable. May not be true. But anyway, it gives you a rough idea. If it was constant, then V average would just be 0, which is what it started at, plus 100 kilometers per hour, divided by 2 is 50 kilometers per hour. So both cars have 50 kilometers per hour as their average speed for both. So it's weird. You would think the Toyota or the Porsche would be faster than the Toyota, but during this test, they both have the same average speed because they both, the test is defined as starting at 0 and getting to 100. So anyway, so T is longer, quite a bit longer for Camry, so it'll go farther. D is farther. Does that make sense? There's probably other ways of thinking about that. Yeah, you can find the times, yeah, for sure. Find the distances if you want. But just this is thinking of it conceptually. During the test, if their acceleration is constant, they'll both have an average speed of 50 kilometers per hour. Okay, I wanted to talk about the speed skater. This is another one of these equations of constant acceleration ones. A speed skater moving across frictionless ice at 8 meters per second hits a 5 meter wide patch of rough ice. She slows steadily, then continues on at 6 meters per second. So let's try to draw that. She starts with V initial equals 8 meters per second. I'm going to actually define plus equals to the right. So we'll put a plus on that. And then she slows steadily over a patch that's 5 meters wide. And then at the end, the final is equal to plus 6 meters per second. So we need the magnitude of A on rough patch. So basic idea is we'll assume A is negative and constant on the rough patch. And so if we list our knowns here, what's known is we know the initial velocity, we know the final velocity, which doesn't have an F. We know x minus x0 is the 5 meters. And what we need is A. What we don't care about in this problem is the time. Time is neither given as one of the knowns, neither is it requested as well. How long does it take? So the equation we'll use is 2.7 because it doesn't have t. And we're going to solve for A. So it is going to be 2 times A times x minus x0 is equal to v squared minus v0 squared. That's equation 2.7. Solving it out for A, get the A is equal to v squared minus v0 squared, all divided by 2 times x minus x0. and just plug that in. You're going to get 6 squared minus 8 squared divided by 2, oops, x minus x0, that's 5. 2 times 5. And I got negative 2.8 meters per second squared, which makes sense. It's slowing down, right? And so the magnitude of the acceleration is because that was what you asked for, 2.8 meters per second squared. The box around that. And it's less than g. Less than gravity. So it's reasonable. Okay. Let me go to the hands. So people have been, all the blood is draining out of your hands. How about Catherine Sean? Did you have a question?
Hi.
Hi.
Can you hear me?
I can hear you just fine, yeah.
Yeah. So when we're doing problems with to do where the acceleration is g, so like this acceleration of free fall, do we write it as 9.8 or 9.81 or 10?
So in this
Or
class, we're going to use 9.8. And in fact,
Okay.
that's true to 3 significant digits. So it's 9.80 is another way of putting it. So
Okay.
just
Thank
by convention. That's a great question. Who else has hands raised here? Who hasn't talked? I've got Anurag.
Yeah, so in this problem, you like put the like absolute value of the acceleration as 2.8.
Yeah.
Is the reason we're not writing negative 2.8 meters per second squared because it says magnitude, or?
Yeah, exactly.
Okay.
I think if it had just said what is the acceleration on the rough ice, then I would have put negative 2.8 meters per second squared because I defined positive being to the right. So, but it specifically said in the question, what is the magnitude of her acceleration? So that's why I took the absolute value.
Okay.
So,
All right.
good point. Cool. Okay. What else did I want to do here? We'll do another question. Oops.
Shiny got the fatty.
How do we mute? There we go. Awesome. Okay, so in an 8-kilometer race, one runner runs at a steady 11 kilometers per hour and another runs 14 kilometers per hour. So there's a race, which is 8 kilometers from here to here. How far from the finish line is the slower runner when the faster runner finishes the race? So I'm going to say that the fast runner finishes in T1 seconds, something like that. And then over that time, here's T1. This is the slow runner. Runs X. And then there's some distance, find, I don't know what to call it, maybe C, where X plus C equals 8 kilometers. How far from the finish line is it? These are constant speeds. Okay. So V of the fast is going to be 8 kilometers divided by T1. So T1 is equal to 8 kilometers divided by 14 kilometers per hour. And then X, so slow runner, kind of mixing these up a little bit here. The slow is equal to X, which is not 8 kilometers, divided by T1, same T1. So I'm going to solve this one for X, V slow multiplied times T1. So you're going to have 11 kilometers per hour times 8 kilometers per hour. Kilometers divided by 14 kilometers per hour. And then C is going to be 8 minus X. So I'm actually going to solve that one out because we've only got about 5 minutes and I want a little bit more time for some questions and stuff. Let me just go to questions. Again, a lot of people still asking what happens if you don't get a practical link. I mean, if your practical comes and goes and there is no link that you get, you can't go to practical. So that's going to be a big problem. I hope it's not a problem with your email and that you know, it doesn't just come and go because you don't know how to check your UToronto email. But presumably before practical starts, maybe it'll only be 20 seconds, but you'll get a link to a Microsoft Team link and you can click in. Looking at other questions here. What chapters exactly will be included in the coming midterm? So it's chapters 1, 2, and 3, but all these questions are from chapter 2. Oh, here we go. My practical is tomorrow, and I just received the link literally 5 minutes ago. So they are coming out. And it could be that, you know, this morning's Monday, and so April is sending out a lot of links today, and also Carolyn's working on it. And then there's a hand up from Samantha. Did you have a question?
Hi, I was wondering about that previous question with the 2 cars.
Yeah, the portion and the camera, yeah.
Yeah, could you go back to that slide?
Yeah.
So I was wondering, like, why, I still don't understand why it's a...
Well, you know what? There's another way of thinking about it, which is that the distance is equal to 1/2 AT squared. So if something starts from rest, and this is the distance. So the Porsche has a higher acceleration, but it has a smaller time. I'm going to actually mute you. Okay. And so, oh, you've muted, which is good. So which matters more? So the t is squared. So maybe the acceleration of the Porsche is higher than the Camry by a factor of like 6.5 over 2.6, but the time is higher for the Camry by that same ratio. And since the t is squared, it counts for more. The fact that it takes longer means it goes farther. So I hope that helps a bit. Let's do one more poll. Heather and Jerry are standing on a bridge 50 meters above a river. Heather throws a rock straight down with a speed of 20 meters per second. Jerry, at the exact same instant of time, throws a rock straight up with the same speed. So one goes up 20 meters per second. The other one goes, sorry, that was Jerry. And then the other one goes straight down 20 meters per second. And then so one goes up woo, like that, and one goes straight down. Which rock has the faster speed as it hits the water? A, the rock that Heather threw, which is the straight down one. B, the rock that Jerry threw, which went up and down. Or C, both rocks will have the same speed as they hit the water. So what my thinking here is, I'm just leave that poll open a little bit. But in both cases, what you've got is you've got this distance sort of y minus y initial or something. You know that. It'll be some distance. That'll be important. You'll also know V0, and you're trying to find V. If I was going to do this, I don't care about the time. Now, not everything's given here, but I would use, if I did have all these numbers, I would use equation 2.7, which was the one that's 2a times y minus y initial is equal to v squared minus v initial squared. And so v squared is just equal to v initial squared plus 2 times a times y minus y0. And what I think is really interesting here is that this one is the same. So negative 20 squared equals positive 20 squared. Same for both. Also, acceleration for both is going to be, I guess the negative 9.8, and this distance will be the same for both as well. Same. So it's because this thing is squared, negative 20 and plus 20, it doesn't matter which way the rock went. So that was what I was looking for. And actually 49% of you managed to get that one, so that's a pretty tricky one. So that's it for today's class. I will stay around. I'm going to turn off the recording and I'll stay around and try to deal with questions of people whose hands are raised, who haven't asked a question. On Wednesday, I'm going to be going through the first three sections of chapter 3 on force, representing forces with vectors, and how is force related to motion. Hopefully we'll be back in the classroom and doing maybe a demonstration or something like that. So thanks very much and good luck with practicals. I certainly hope all of you get your link before you get to practical. Okay.